In this video, we are going to find the intervals on which the function f of x equals 2x cubed minus 15x squared plus 24x minus 5 is increasing or decreasing, and we're also going to find the local maximum and minimum values of f. So where do we begin? Well, first, we want to take the derivative of this function f of x. So we have that f of x equals 2x cubed minus 15x squared plus 24x minus 5. So if we take the derivative, what's the derivative of 2x cubed? It's going to be 2 times 3x squared. What's the derivative of minus 15x squared? It's going to be minus 15 times 2x. What's the derivative of 24x? It's just 24. And what's the derivative of minus 5? That's a constant, so it's just 0. So this is equal to 6x squared minus 30x plus 24. Now notice 6, 30, and 24 are all divisible by 6. So we can factor out a 6, and this becomes x squared minus 5x plus 4. Now notice x squared minus 5x plus 4 can be factored as follows. So this is x minus 4 times x minus 1. Great. So whenever you have a question that's asking you to find where a function is increasing or decreasing, you want to find the critical numbers. How do you do that? You take the derivative of that function and set it equal to 0. And see for which values of x does that function equal 0. Those values are called critical numbers, and they're going to be the possible maximums or minimums of this function. So if we set this function, or if we set the derivative of this function equal to 0, so if I set this equal to 0, then that means that x equals 1 or 4. Great. So now we're going to plot the critical numbers on a number line. And we want to find, you see here we have 3 intervals, right? We want to find on which intervals this is increasing or decreasing. So we're going to want to plug in some values in each interval into the derivative. If the derivative is positive, so if f prime of x is greater than 0 on a certain interval, let's say on the interval a comma b, then that means that f of x is increasing on that interval. Now, if the derivative is negative, so if f prime of x is less than 0 on some interval ab, then that means that f of x is decreasing on that interval ab. So let's choose some numbers in each interval. Let's say I'm going to choose 0 in this interval, 2 in this interval, and 5 in this interval. So what is f prime of 0? That's going to be 6 times 0 minus 4 times 0 minus 1. Now we don't actually care about what this value is. We just care if it's positive or negative. So we see that this value here is negative. This value here is negative. So negative times negative is going to give me positive. So that means that f prime is positive on the interval minus infinity to 1. Now what if I plug in 2? So if I evaluate the derivative at 2, that's 6 times 2 minus 4 times 2 minus 1. Again, I don't really care what this value is. I just care if it's positive or negative. 2 minus 4 is going to be negative. 2 minus 1 is going to be positive. So negative times positive, also times positive because of the 6, is negative. So from 1 to 4, the derivative is negative. Now let's plug in 5 into the derivative. We have 6 times 5 minus 4 times 5 minus 1. 5 minus 4 is positive. 5 minus 1 also positive. So this is going to be positive. Great. So what does this tell me? This tells me that the function f of x is increasing on the intervals where the derivative is positive. So on minus infinity to 1 and 4 to positive infinity. And f of x is decreasing where the derivative is negative, so that's on the interval 1, 4. Great. Now the next part of the question asks us to also find the local maximum and minimum values of f. Now what do we know about that? Well, we know that if f prime of x goes from positive to negative at, let's say, x equals a, then x equals a is a local maximum. If f prime of x goes from being negative to positive, so decreasing to increasing at x equals a, then x equals a is a local minimum. And this makes sense, right? If we have some derivative that's going from being increasing to decreasing, then this is going to be a maximum. If it's going from decreasing to increasing, so negative to positive, then we're going to get a minimum at that point. So if we look at what we have gathered, we see that at x equals 1, the derivative goes from being positive to negative. So that means that x equals 1 is a local maximum. So we can say there is a local maximum of f at x equals 1. Now what's the actual point? So then we would plug in 1 into f of x. So f of 1 is going to be 2 times 1 cubed minus 15 times 1 squared plus 24 times 1 minus 5. So note that I'm plugging this into the actual function f, not its derivative. And so if you evaluate this, you get 2 minus 15 plus 24 minus 5, and this is 6. So there's a local maximum of f at x equals 1, i.e. the point 1, 6. Okay, now are there any local minimums? Let's see. So at x equals 4, we see that the derivative goes from being negative to positive. So that means that at x equals 4, there's a local minimum. Again, we actually want the point, so we can plug in 4 into f. This is 2 times 4 cubed minus 15 times 4 squared plus 24 times 4 minus 5. This turns out to be minus 21. So there's a local minimum at the point 4, negative 21. And so that pretty much fully answers this question. We found where this function f of x is increasing or decreasing by taking the derivative of the function, setting it equal to 0, finding the critical numbers, and then checking which intervals f prime is positive or negative, which tells us where f is increasing or decreasing. Then we use that information to find, or to determine rather, whether those critical numbers are local maximums or minimums. And it turns out that one of them is a local maximum and the other is a local minimum. If this video is helpful, feel free to like and subscribe.